Alright, in this video we're going to talk about 6.1 day 2, the distance between a point and a line. So the distance between a point and a line, with the point not being on the line, is going to be defined as the perpendicular segment connecting the point and the line. So we're going to find the shortest distance between the point and the line and call that the actual distance. So to find the distance between the point and the line, we need to think about the point. We're going to call it x1, y1, and we're going to think about the line in standard form. So ax plus by equals plus c equals 0. And then our distance d is going to be the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. So a, b, and c are the coefficients of our line in standard form, not slope-intercept form. And x1, y1 is just the point. So let's look at a real quick example. Find the distance between the point 4, 1 and the line y equals 2x plus 1. So our formula is going to say that the distance is equal to the absolute value of ax1 plus by1 plus c over the square root of ax squared plus b squared, a squared plus b squared, no x. So we need to find what a, b, c, x1, and y1 are. Well, they tell us here that x1, y1 is 4, 1. We need to rewrite this in standard form. So we need to make sure everything is on the same side. So we're going to take everything, move it over to the left, and we're going to say negative 2x plus y minus 1 equals 0. So now we know a is negative 2, b is 1, c is negative 1. So what we need to do now is just throw everything into our equation here. So we're going to say the absolute value of negative 2 times 4 plus 1 times 1 plus a negative 1. So the absolute value of all of that stuff divided by the square root of negative 2 squared plus 1 squared. If we work that out, we're going to get approximately 3.58. So whatever our units would be, we're 3.58 units from this point to this line. Now, one thing that we can use this distance for is to find the area of triangles. So find the area of the triangle with vertices negative 3, 0, 0, 4, and 5, 2. So we know, among other things, that the area of a triangle can be 1/2 base times height. And we know that the base and the height have to be perpendicular. That's how we're going to get the base and the height. So this idea of perpendicular, we can use the length of, or the distance between a point and a line, we can make it the distance between one of our vertices and one of the sides, and that's going to give us a perpendicular segment, so that's going to give us the height of the triangle. So just to kind of get an idea, just a rough sketch of where these things are, what this looks like, negative 3, 0, 0, 4, 5, 2, looks something like that. Again, just a rough sketch. So we could, if we wanted to, make any of these things. Like we can make a perpendicular segment from C to the side AB. We can make one from B to the side AC. We can make one from A to the side BC. Any of those things are going to be fine. But just for the ease of looking at this thing, it's going to be easiest to look at this perpendicular segment here from B to the line AC. So if we're thinking about the length of that height, so we can see the height has a length of the square root, and this is, the absolute value of ax1 plus by1, right? So our formula plus c over the square root of a squared plus b squared. Now we just got to figure out what x1, y1, a, b, and c are. So x1, y1 is the point. It's the point B here. So we know x1, y1 is 0, 4. And we're going to the line connecting AC. So we need to come up with the equation of the line connecting AC. Well, we need a point, we need a slope, and then we can come up with the point-slope form of the equation, and we can turn that into the general form. So any of the points would work. I like the point with 0, because that's going to make it a little bit easier to use. So we have a point here. Slope, if I go from A to C, I'm going up 2, and I'm going over 8. So slope is going to be 2 over 8, which is 1/4. So I have a point, I have a slope, I can put this into point-slope form, so y minus 0 equals 1/4 x plus 3. So y equals 1/4 x plus 3/4. To be in standard form, we need to multiply everything by 4 to get rid of our fractions. So we can say 4y equals x plus 3. Move everything over to the other side. Let's move the 4 over this side this time, just to kind of show you that it doesn't matter which way we move things. So we'll say x minus 4y plus 3 equals 0. So we know a is 1, b is negative 4, and c is equal to 3. So to find the height, we're going to say that that's the absolute value of 1 times x1, which is 0, plus b, so negative 4, times y1, which was 4, plus c, which was 3. And we're going to go over the square root of 1 squared plus negative 4 squared. Working that out, you're going to get 13 over radical 17. So the height is 13 over radical 17. So we have that part. Now we just need to find the base. The base is going to be the length of the segment AC. So if we think about that, we can say the base is going to be equal to, using our distance formula from geometry, we're going to say the square root of, we're going to take this first point, the difference of the x values, so negative 3 minus 5 squared, plus the difference of the y values, 0 minus 2 squared. Take the square root of that, and that's going to turn out to be radical 68, which when we simplify it is going to be 2 radical 17. So our area is 1/2 the base, 2 radical 17, times the height, 13 over radical 17. And a lot of this stuff's going to cancel out. So if we look, we have a 1/2 times a 2. We have a radical 17 in the numerator, a radical 17 in the denominator. So our area here turns out to be just 13. So that's going to do it for this video. We will see you in the next one.